Hello, Thomas. I need your help. I'm stuck in blockchain. I will explain you the situation. Suppose I have a contract which has a function that accepts arguments. So the problem is, I don't know how to do it using JavaScript. Kindly help me. Thanks and regards. So yes, I can help you with this, and in this video I'm going to show you two different ways how to access your Solidity deployed contracts from your JavaScript. First, I'm going to show you how to do this with Web3.js, and then I'm going to show you how to do this with Truffle-Contract and why I actually prefer the Truffle-Contract library over Web3.js. So I have a simple index.html file here, and you can find the code also in the link below in the description to this video. I've also opened Remix with a simple smart contract, and I have Ganache running. So Ganache is restarted. There is 0 transactions here. Every account here is 100 Ether. So I'm really starting from scratch. Here in Remix, I have a very simple smart contract. Let me make this a little bit bigger so you can see what's going on. I have a contract called Ethereum Session, and then I have one unsigned integer storage variable here, two functions, very, very simplistic. Set the integer, gets an argument, it's public, and get the integer is a view function and returns our integer that we set before. So it's a very simplistic example just to show you how things are working. I'm going to take this contract now and I'm going to deploy it into my Ganache. For this, I have to connect with the RPC server from Ganache. And this is the first thing that should stand out if you want to somehow interact with the website with your blockchain node. This is the RPC, the json-rpc server over HTTP. So you can connect to this address with your JavaScript. And this happens internally in Remix. And then you can talk to your blockchain node via this RPC server. So in this case, I'm going to head over to the Run tab over here, and then I choose the right environment. There are 3 different environments. I'm going to explain these environments in my courses on Udemy. You can also find the link below in the description. And for this example, I'm going to choose the Web3 provider so I can directly connect to my blockchain node. Now I'm going to set the right port. As you can see, localhost 7545 in Ganache, it's localhost 7545. I could also copy and paste this. And then I'm going to connect to this. And after a short moment, I should see the correct network ID 5777. And I should see that I have 10 accounts with 100 Ether each. So as you can see in Remix here, it's 20 accounts, but it's actually a copy. So they are duplicated. And now I can just hit on deploy. And I'm going to deploy my smart contracts in Ganache. They should actually pop up very, very quickly. So here we go. We have our instance of our deployed contract here. I could set something now, and then I could also get back the result again. So I can interact with my smart contract via these buttons. So what happens internally in Remix is that it's firing off requests to this JSON-rpc from Ganache, and Ganache understands these JSON packages. You can actually follow them along if you hit F12 in your browser and you do something. You can see that it's sending off requests to localhost 7545 post requests, and there it sends off want to get the balance of this account, and then there's an answer coming back from your blockchain node saying, okay, this account has so and so much balance. There is a list of these commands. You can find them here on GitHub in the Ethereum wiki. So all of these commands, these JSON commands are listed, but we will not go too much into detail of those. I just want to show you how you can actually interact with your HTML site or with JavaScript from any library, from any framework, or wherever you're working off on a lower level now, so you understand what's going on behind the scenes. So what I want to do is I want to take this smart contract and tell my JavaScript that I have here, how to interact with this smart contract. And for this, I will first use this Web3.js library. And I want to go with you now step by step through this script part of the HTML site and tell you what's going on. So the first part is basically a copy and paste from the Web3 website. This part says if you're using a plugin like MetaMask, then Web3 will automatically be included in the website. And then it will just try to connect to this MetaMask plugin or another plugin that you might use for your browser. But in our case, I'm using Firefox without any MetaMask. So we will try to connect directly to a blockchain node and send requests there via this json-rpc interface. Now, in our case, I want to try to connect to Ganache. And again, Ganache is running on this localhost 7545. So this is how we connect to this. So then Web3 knows, okay, we are going to connect to this node and I'm ready to take commands. And there are several things that you can do with Web3. One of them would be to send transactions, raw transactions, or to get the balance for an account, or to get the accounts from the key store in Ganache. But that's not what we want to do. We want to actually create a contract and a contract instance. And to do that, we have these two functions here. First, we are creating the contract with web3.eth.contract. And I want to head over to the Web3 documentation for this purpose. And I want to show you where this actually is. Web3.eth.contract. So here we have this function that accepts this ABI array. And an ABI array is an application binary interface which describes the smart contract so that JavaScript knows how to interact with the smart contract that is deployed on the blockchain. Because if you are going to deploy a smart contract on a blockchain, then essentially there's just bytecode running. So after the deployment, the outside libraries or interfaces don't know how to interact with this smart contract. For this, there is the ABI array, and the ABI array is created by the compiler. In this case, we are using Remix to compile our smart contract, the Sol-C, the JavaScript version of Sol-C, and it will output the ABI here. If you go to compile and details, then you find the ABI array besides a couple of other details about this contract over here in this pop-up. And you can just click on this copy value to clipboard. And then very simple, just paste it over here where it says web3.eth.contract. There you paste the ABI array. How does it look like? So the ABI array is a JSON formatted array with all the interfaces and everything which allows you to interact with your smart contract from outside. That means you have the setInt function, which is a type of a function, and you also have the input arguments that it takes, so that the outside library knows how to correctly encode those input arguments for the blockchain node. They must be encoded in a specific way. In this case, it must be a 256 bits long hex encoded string. And if I would just input the number 1, then it has to pad the string up to 256 bits and so on. So therefore, all of the data types, there is a specific input encoding and output encoding or decoding in this case, which is necessary. Also, the name of the function is very, very important because you need, or the library needs the name and the input types to create the function signature, and that way tell the blockchain node how to correctly approach this function, which is running under a certain address. Then we have our getInt function. We have here the output arguments. We see that there are no input arguments, so that if we get a result back, our library knows how to properly decode that result. Talking enough about the ABI array. Now we know, or now our Web3 knows how to interact with this blockchain smart contract, but it doesn't know where. So we need that address for that. And the address is the address of the instance that we deployed earlier over here. So we click deploy, and that way we get a deployed contract, and that's running on a specific address. And I can also just copy this address over here and then paste it here. Now what do I get back? An Ethereum Session instance. And with this Ethereum Session instance, I can do things like set the int and get the int. And this way I can really access our functions that we have in our remix, in our smart contract, right here in JavaScript. And our JavaScript Web3 contract instance will take care of properly encoding the input arguments and will take care of properly encoding this function signature and packaging everything into a request against our blockchain node, an AJAX request against our blockchain node, against this RPC server. So this is basically how this works. And now I would say, let's just give it a try. I hit save and I head over to my browser. I have this site open here. So I really just open the site in my browser. I hit F5 and reference is not defined. Okay, what did I miss? I missed to install our actually our Web3. Where do I get that from? Web3, in my case, will be a node package that I install with the node package manager. So I can just type in npm install Web3. But the recent versions of Web3 have a problem with cores. I actually posted an issue to that. So that's the issue that I posted. It's marked as a bug. This is why I will install a slightly older version of Web3, 0.26. So with 0.26, there's the latest change is not included, which breaks cores in my case. So I will install Web3 0.26, and this will download Web3 into the node modules folder, and then I can just access this. And at the same time, I will also already install Truffle-Contract, which we will use in a second for our second version, how to access the blockchain node from our JavaScript. In a second, it should be installed. All right, we have Web3 installed, some warnings, but we don't care about the warnings here. npm install Truffle-Contract. So for the second part, I will download Truffle-Contract. I will tell you in a second what Truffle-Contract is and why I actually want to use Truffle-Contract instead of Web3. In case you run into any problems, I'm using Truffle-Contract version 3.06 here. So if you have any problems with Truffle-Contract, maybe you also can try to install Truffle version 3.06. This way I also install Web3. All right, now let's try and reload the page. And we see we have some output here. Where is this output coming from? This output comes from the console log statement here. Get the int. We set the int first to 1, 2, 3, and we get the int back. Now, obviously, because we're connected with our remix to the same instance, we can also hit get the int here, and we can get the same number back that we set before in our HTML. Very cool. Where's the problem with that? Here, we set the int and we would actually have to wait for the mining to take place. Let me show you this in an example what I mean. So I'm here in Ganache and I disable the auto mine function and I type in a 5 seconds block mining time. That means every 5 seconds a new block will be created. You can see this over here that the current block is 0 and now it's 1, and every 5 seconds it will jump up one more block, regardless if there is a transaction or not. With the automine function, new blocks will only be created if there is a transaction happening. And that way, the transaction is immediately included in a block and immediately available. Now here, we have to wait until the block is actually mined, so we get back a result. Now, because I have restarted Ganache, I also have to redeploy our smart contract. Let me reload Remix. All right, Remix is reloaded. Let me set the environment again to our Web3 provider. Then it will take a while till okay. accounts are loaded, and now I hit deploy, and now I already see creation of Ethereum session is pending for a little bit longer. I don't need to copy the address again because the address is actually not random. The address is a result of the account that sends off the transaction plus the nonce. The nonce is an index that gets incremented every time a transaction is sent. So from our address where we send off the transaction, we have now one transaction sent, and before we also have one transaction sent. So the nonce is the same, the address is the same, and the account address, the contract address will also be the same again. And the contract is currently totally empty. There is nothing written yet. And I'm going to reload the page now. And then you will see what I mean with the transaction has to be mined before a result is available. Now I get 0 back, but I should actually get back 1, 2, 3, 4. So why do I get 0 back? We write in this line, in the line 60 in our code, we call the set the int function with 1, 2, 3, 4. Our transaction is recognized by Ganache, but is not yet in a block. So let's say we are in block 40. For whatever example reason, we are in block 40 and we set off this transaction 1, 2, 3, 4. But our transaction would actually be only included in block 41. So because there's almost no time between these two calls in JavaScript, we will get back the result from get the int, also from block 40, because block 41 is not yet mined. So we will actually have to wait until this transaction is ready in a block. So what happens if I set off a transaction in JavaScript? I get back a transaction hash. Let me show you this. I set Ethereum Session instance get the int in my console here in the index.html. And I get back a transaction hash. And I would normally have to do now get transaction receipt from this transaction hash and get back a transaction hash if the transaction is in a block integrated. Now what happens if I do this instead, where I know that I get back the transaction hash and I get a null. And the reason is I set off this transaction inside the function get the transaction receipt, get back the transaction hash, and immediately say to Web3, okay, give me the transaction receipt from this transaction hash that comes back here by calling the set the int function. And that's not yet in a block, so that's not yet mined. So there is no transaction receipt and we get back null. So what we would have to do instead is we would have to call now this get transaction receipt, maybe in a timeout or something, every 500 milliseconds until we get back a transaction receipt. And then we can call the get the int function, because only then this result is really mined and is really baked in the block in the blockchain. Now there is a better way. Let me show you this better way. That's with Truffle-Contract. And Truffle-Contract works with promises. I uncomment this here. Works a little bit different than Web3, but essentially the same way. Let me open the Truffle-Contract website here. The Truffle-Contract library is a part of the Truffle framework, the Truffle suite. And it's not recommended anymore to really install the Truffle-Contract library standalone. But if you head over to truffleframework.com, then you see that there are a couple of tools that are really, really interesting for smart contract developers. And I'm talking about this in my courses as well. Very extensively, we're using Truffle and Truffle boxes there. And what you want to do is you want to go into the Truffle part and you see how you can install Truffle. All right, but there are also Truffle boxes. And if you are a React developer, or if you come from any other framework out there, you will find a good starting point for your project. And in this case, if you work with Truffle boxes, you can just type in Truffle, or here in the console, Truffle, unbox, and then the box name. So for example, React. And this will download the React repository behind this Truffle box. You have the install instructions here, Truffle unbox React. And it will download this GitHub repository. And it will run npm install for you. And then you're basically ready to start using this. And in that case, you have all your contracts and your migrations for deployments and your tests and your actual HTML, JavaScript, CSS in one project folder, which you can then share with teams and so on. So I'm not going to do this. I'm going to show you this on a lower level now because you were interested in how to actually interact with the blockchain node. All right, so we have still our HTML page, and I'm going to show you now how to do this. So in Truffle, in Web3, we have this ABI array over here with Web3 ETH contract. In Truffle contract, that looks slightly different. In Truffle contract, you have this Truffle contract call, and then it needs an actual config object. And inside this config object, there is one element that is not optional. Everything else is optional. The non-optional element is the ABI array, so that Truffle contract knows how to interact with this contract. And then it gives you back this contract itself. But then you have to tell this contract how to interact, where on which address, and how to interact with this contract. So the first thing that it needs is the provider, which is very similar to Web3 provider over here on the top. So we say Web3 is new Web3 and then a Web3 provider. In our Truffle contract version, we say, okay, we first create the provider over here, Web3 providers HTTP provider, and say again, connect to localhost 7545, our ganache. And then we give it the provider over here with set provider. Could also be WebSockets or other providers, which I don't know yet from the top of my head. And then we can say that contract runs at a specific address. And here we can give it the same address as we have over here because it's the same smart contract. But then comes the interesting part. Truffle contract runs with promises. So once it gets the address, it gives you back a promise, and promises are resolved in the then branch. And there you get back the instance of the contract. So this is where I'm going to assign this ES Truffle instance, Ethereum Session Truffle instance, the instance I get back here. At the same time, I log this instance so that you can see what is going on, which we'll do in a second. But then comes the interesting part. I have the instance and I call set the int and set it to 4545 or any other random number. So that's a totally random number, but the set the int and the return statement is the important part, because this one will give you a promise as well. And this promise only resolves if this function, if the transaction that happens because of this function call is mined. And then you go back to the then branch, and here you only go into this then branch when this is already baked in the blockchain. So instead of having to wait for the transaction to be mined, you are just calling the then branch for the promise that will be returned here. And then you're ready to call the next function call against your smart contract. And here, get the int, you also get back a promise. This will resolve pretty fast because it's only a call. And then you get the result, and then I output the result. So here I'm expecting 4545. Well, let me change this over here to 4546. So this one should still output 1, 2, 3, 4, 5 because we're not waiting. And this one should actually output 4545. I would say let's give it a try. Let's see what happens. I'm just gonna reload the page over here and hope I didn't make any typos. So this is the first one. This is 1, 2, 3, 4, 5, and should actually be 45, 46. And then we have over here, we have our contract instance. And then we have our 45, 45 here. Again, you saw maybe that it took a few seconds until that was available. So it's not immediately available because the transaction first needs to be mined in our ganache, and our ganache is set to a 5 seconds block mining time. So that's all there is for this Ethereum session that I wanted to show you. If you liked this video, then subscribe to my YouTube channel. I will post from time to time more of them. If you want to have anything else covered, then just let me know in the comments. I'm happy to see if I can make an Ethereum session. And other than that, I wish you a beautiful day and good luck with your smart contracts and with your JavaScript.